Hello everyone. In today's video, we will be discussing recommendation systems which are very used nowadays. To start with, recommendation systems are software tools or techniques that provide recommendations for a product or a service that may be useful to a user. It helps at the same time users to deal with information overload and businesses to make more profits. This assignment is inspired by Netflix. We all know that Netflix suggests movies based on each user profile. So we tried to do the same thing in this assignment. We built a movie recommendation system using SVD, Singular Value Decomposition. It's a matrix factorization technique that breaks down a large sparse user item matrix into smaller matrices that are easy to handle and that capture actually latent features to reveal some hidden patterns in order to predict user preferences. We will be using some very known Python libraries such as pandas for data handling, matplotlib for visualization, but mainly Surprise, which is very known and used for collaborative filtering, SVD, and scikit-learn, which is a very known machine learning library. So we worked on the MovieLens 25 million datasets, which contains 25 million ratings from 62,423 movies and uses 1 million tags. To start, we needed to understand our data. This is why we use different visualization in order to understand our data more and have the possibility to work with it correctly. So as we can see in the left side, it's a visualization that represents the rate and frequency distribution, in which we can easily see that user ratings are skewed with 4 and 3 most stars, and we only have few 1 stars. In the right visualization, which represent the cumulative rating distribution, it zoom out that over 60% of ratings are 3.5 stars or higher, which highlight the fact that users enjoy their movies, and this may create a huge problem. This is why we should avoid recommending popular titles, popular movies. We visualized as well the user activity and movie popularity, and here sparsity is very clear in our datasets, which is our big challenge. We can see that most users rate fewer than 10 movies, and we have at the same time tiny fraction of movies that gets thousands of rating. Sparsity, as I said, is the big challenge. This is why SVD is a good fit for this dataset. We visualize movie types distribution, and here we have a very bad distribution because, as we can see, drama and comedy dominates, where musical or fantasy, for example, are very rare. We visualize at the same time the rating activity over time and the monthly rating patterns. And here we have seasonal trends. For example, in the right visualization, we can see that we have more ratings in the winter. This was the first step in our assignments. I will let you with my colleague Yassine to explain to you what we did as a second step, which is the data preprocessing and feature engineering.
Very good. So now let's move on to the pre-processing and feature engineering step. This is a crucial step in every machine learning project, as you already know, because basically a clean and well-organized data set helps the model make better predictions or decision. We also added some extra information to enrich the data and removed anything that could confuse the model. And in the first step we added extra features about movies, since the MovieLens dataset includes a separate file with tags and relevant scores, like how much a movie is related to like romance or action or adventure or whatever genre of movies. So we combine this data so that we have a new matrix. Now we have each row is a movie, each column is a tag, and each value tells us how relevant that tag is for this movie. Then we moved on to the next step. Here we solve something called the co-stars problem, and this is basically when a user or a movie has only a few ratings and the model cannot learn anything useful from it. So in order to fix this, we removed any user or movie that had fewer than 5 ratings. Then we move on to time-based train or test and validation splits. So here, instead of splitting the data randomly, we sorted all the ratings based on time from oldest to newest, and this way we trained the model on older data and tested it on newer ratings, which is how I guess it works in real life. Here we used 70% of the data for training model. We multiplied 0.7 times the length of the ratings, which is the whole data set of the ratings, and in this data set we have 25 million of ratings. So we ended up having 17 millions only for the training, and 15% for validation, and the rest, which is another 15% for the testing. Then now, since the data is clean and ready, we move on to training our recommendation model. So we use the technique which is called SVD as it is required, which is the abbreviation of Singular Value Decomposition. So basically SVD is a method that finds hidden patterns between users and movies. It helps us understand what kind of movies a user likes, even if they haven't watched them yet. So for the training of the model, first we loaded our training data used in the surprise library. We used this reader function from the surprise library. So basically this library is designed specifically for building a recommendation system. So we told it the range of the ratings from 0.5 till 5, since the max of the ratings that we have on the datasets is 5 stars. So then created the full training sets. After that we created the SVD model and trained it. During the training the model learns two things: what kind of movies each user prefers and what hidden features each movie has, like action, romance, as we already mentioned before, which are the genre of the movies. And here for the visualization of the learned movie features. After the training step we created a heat map to visualize what the model learned. So each row here in this heat map represents a movie, and each column represents a hidden feature. So the colors show how strongly a movie connects to each feature. Here, as you can see, the red means a strong positive connection, and the blue means a strong negative connection. So this plot proves that the model is learning real patterns in the data instead of just memorizing the ratings. And for the evaluation on the validation sets, so we then tested how well the model performs using the validation sets for each rating the model predicted how much the user would like the movie. Then we compared the prediction to the actual rating. We used the two standard metrics, which are the RMSE, which stands for root mean squared error. This exactly tells us how big the error are, and this shows the average error. And MAE, which stands for mean absolute error. So the scores that we have got were low, which is good, which is a good sign. It means the model is making accurate predictions. Okay.
So after building a basic SVD model, we decided to optimize it even more and use grid search. In the grid search, as you can see, we used number factors, which represent how many hidden features the model learns, learning rates, regularization method, and number of epochs, which is the training iterations. We get as best parameters 50 as factor, 0.005 in the learning rate, 0.02 as regularization, and 30 epochs. And an RMSE score of 0.79. We can say that this model is optimized for rating prediction. Okay? Now we should understand what is a hybrid model. To do so, we should understand the three approaches used in recommendation systems. We have the collaborative filtering, which is the most used, which under which we have the SVD, which is a dimensionality reduction, as I explained earlier in the definition. But we also have a content-based recommendation. So to make the difference, the collaborative filtering recommend based on similar tastes. For example, if I do like drama movies and Yassine have a similar taste as me, if I give 4 stars to a movie, the system, based on my taste and considering that me and Yassine has the same taste, it will recommend this exact movie that I well rated to Yassine. Okay? In the content based, we don't use the user profile. We base the recommendation on the information of the movie. Okay, so in this assignment, we use the hybrid method, which can combine both content-based recommendation and collaborative filtering recommendation, which is the SVD. All that to handle one of the biggest problems of collaborative filtering, which is called start problem, which means the system will find it very hard to handle new movies. Okay, so we did some content features, dimensionality reduction, and the main parts, which is we merged the SVD collaborative recommendation with the content-based recommendation. It gives as an RMSE 1.44 and MAE 1.26. So here we can see that we have a worse RMSE compared to the grid search. Okay, but a better coverage since it resolved the problem of cold start case scenario where the SVD fails. So here are the 3 models we trained. You will discover a comprehensive evaluation and recommendation with my colleague Yassine. Thank you.
Again, after validating the model, we tested it on completely new data that the model had never seen before. This is the final check to see if the model really works in the real world. So here we are evaluating the model on full test sets. We did that in batches. We have created this method to to avoid memory crashes while still using all of the data rather than using only some sample of data like 1000 or whatever number of the data. So we have used the whole test set, and again we use the RMSE and the MAE, which are the error scores, and the final score showed that the model performs well even on totally new data. And here it comes the last part, which is the recommendation generation. This is where we show how the model can actually help users discover new movies they are likely to love or enjoy. And we have built this function that picks all the movies a user hasn't rated yet, and it predicts how much the user would like each one. Then it sorts them by predicted rating. So here in the prediction we used the hybrid model, since we have tested all the models. So this is the top one mentioned by my teammates, and this is what powers the recommendation engine on platforms like Netflix or Amazon, which are the well-known platforms for recommendation systems. So finally we picked a random user and generating their top 5 recommended movies. So for each movie we show the predicted rating, and this is the final result of our system, and it shows that our model can give smart personalized suggestion to each user. And in these results we have used another notebook. I will show it to you. So this is the previous notebook, so we can even see the images of the top rating or predicted movies for each user. But since we were using the API from TMDB, which is the platform that the datasets grabbed from, so and the API is limited, so now we cannot retrieve the images from my account. So thanks for watching, have a good day.